Solve v to the 2/3 power plus 7v to the 1/3 power equals -10. Well, this one's a bit tricky. Let's see. So v to the 2/3 power plus 7v to the 1/3 power. And I'll go ahead and bring this 10 over and make this plus 10 equals 0. And if you'll notice, it's sort of in the form of a quadratic, but clearly I don't have an exponent that's highest degree is 2. So allow me to make a substitution. So if I let u be this middle term, that's going to make a linear term here. So u equals v to the 1/3. And what's nice about that is if I square both sides of this equation, I get u squared equals v to the 1/3 squared, which is v to the 2/3. So what that means is I can change my equation into, so v to the 2/3 becomes u squared. Then I have plus 7. Then I'm changing v to the 1/3 into u. Then plus 10 equals 0. Now I've got an equation that is quadratic, which means I can try to factor, see if it will. And I think this one actually will factor because factors of 10 that add up to 7 would be 5 and 2. And if they're both positive, they would multiply to positive 10 and add to positive 7. So two linear factors multiplied together that are equal to 0. I can split that up into two separate equations that's equal to 0 and continue solving. So u equals -5 and u equals -2. But that's not the end of the problem because I had the original variable as v. So I solved it in terms of u, but I need to go back to v. And that's simple enough to do. All I have to do is just take this original transformation that I chose and switch back to v to the 1/3. Same thing here. This would be v to the 1/3. So v to the 1/3 equals -5, and v to the 1/3 equals -2. Now, to continue solving this, what I need to do is I need to raise both sides of this equation to the 3rd power. The reason I'm raising to the 3rd power is because rules of exponents tell me 1/3 times 3 gives me 1. So that would leave me v to the 1st power, or just v. -5 to the 3rd is -125, and -2 to the 3rd is -8.